In this video, I would like to talk about finding the distance between two complex numbers in the complex plane. So here we have our complex plane with our real number axis and our imaginary number axis. And let's take, for example, the two complex numbers -3 plus 5i in red and -1 minus 6i in blue. And let's go ahead and plot those 2 points on our complex plane. And here's the distance that we want to find between these 2 points. And of course, we can create a right triangle from these 2 points. And the dimensions of this right triangle will be a leg length of 2 on the bottom and a leg length of 11 on the side. And so we can use the Pythagorean Theorem actually to find this distance. So a squared plus b squared equals c squared, which would be that distance. So 2 squared and 11 squared will become 4 plus 121, which equals c squared. So that's 125. And when we take the square root of both sides, we'll see that c, or the distance between these two complex numbers in the plane, is 5 radical 5. Well, what we can do now is to kind of generalize the situation, and we can create a formula based on what's going on here in the complex plane. So the distance between two complex numbers in the complex plane is going to be this big square root thing. And of course, we just saw it came from the Pythagorean Theorem. So we have two complex numbers. z1 is a plus bi, and z2 is c plus di. So of course, that first quantity is c minus a, which is the difference in their real parts. And the second quantity is d minus b, which is the difference in the imaginary parts, but without the I. We're just concerned with the coefficient of I, so it's just the b and the d values. So we'll take the square root of the square of these two quantities, and that will be the distance between these two complex numbers in the complex plane. So let's go ahead and work 2 more examples. In this example, I have two complex numbers, -4 plus I and 4 plus 7i, and I would like to find the distance between these two numbers. So of course, they can both be plotted in the complex plane with our real number axis and our imaginary number axis. And -4 plus I will be somewhere over here. And 4 plus 7i is somewhere over here. And of course, we'd like to find this distance here. So we can do so. Our distance formula is a big old square root. And when we have these two complex numbers, we can call this first one a plus bi, and the second one c plus di. So what happens is we're going to subtract their real parts and then square it. And then subtract their imaginary parts, well, the coefficient of the imaginary part, just the b and the d, and then square it. Add those squares together, and then do the square root of the whole thing. And again, that's just Pythagorean Theorem, because what we've done is made a nice right triangle out of these 2 points. So let's go ahead and get going. So the distance is the square root of, so c is going to be 4, minus a, which is -4, and that's squared. So d is 7 minus b, which is 1, and that's squared. Okay, so now it's just working some numbers. So minus a negative, we'll go swoosh swoosh and make that plus. So 4 plus 4 is 8. So I'll go ahead and show my work, 8 squared. And then 7 minus 1 is 6, so 6 squared. So 8 squared is 64, 6 squared is 36, which is the square root of 100, which actually is 10. So that came down to a pretty nice value. So what we're saying is that the distance between these two complex numbers, when I plot them in the complex plane, this distance here is going to be 10 units. In this last example here, we have 2 more complex numbers. We have -2 times the square root of 3 plus 3/4 I, and then negative square root of 3 plus 1/2 I. So again, we could plot them, and it looks like a negative, positive. We'll put them both in the second quadrant over here. So maybe -2 radical 3 plus 3/4, and then negative radical 3 plus a half, something like that. We'll just have this little distance, and it shouldn't be too far. They seem like they're pretty reasonably close to one another. So my distance formula for these complex numbers is going to be c minus a quantity squared, and then d minus b quantity squared, and we'll do the square root of all of that. So what's this ABCD business? Well, remember we have this in a plus bi, and this one we can write in c plus di, because they're both complex numbers in standard form. So we can go ahead and grab these values now. C is negative square root of 3 minus a, which is a negative 2 times the square root of 3. All that's going to be squared. Plus d, which is 1/2, minus b, which is 3/4, and all that's going to be squared. Okay, so let's go slow here. So we have minus and negative, so we'll go swoosh swoosh again here. So negative radical 3 plus 2 radical 3 makes a single radical 3, and that'll be squared. And then plus, let's see, 1/2 minus 3/4 should be negative 1/4, and that will be squared. So the square root of 3 squared just has the square root and the square cancel, so I have 3. And then negative 1/4 squared, the negative squared makes it positive, and the 1/4 makes 1/16 when I square it. So 3 plus a 16th is 3 1/16, or as I make that improper, it'll be 49/16. And the square root of that is nice, just 7/4. So that actually came out pretty nicely. So what I'm saying is 7/4 is the distance here. I could say 7/4 is the distance between these two complex numbers in our complex plane.